Greetings, Earthlings. I wanted to give you an update on the state of this project, the arcade game here, 6809 based arcade game. And we did not arrive here without some difficulty. What I can say, I made some mistakes. We'll start with this thing. This power supply has multiple presets of output voltage. And the default M1, when you power it on, it comes up on M1, not on what you last turned it off, but what M1 is set at. And by default, M1 is set for 15 volts and 3 amps. I had 5 volts down here on M4. And so I would turn it on, and then it goes beep, and I would press M4, and then this is the button that actually turns the power on, delivers the power to the board. Well, I somehow pressed that button instead of the M4 button and sent 15 volts through the board. Not recommended. I think I kind of got lucky because only 3 chips were destroyed. We'll take a look at them here. The the GAL chip right there, if you can see that, that's the decoder chip, which is right here, which decodes the addresses to tell you whether you're doing I/O or reading or writing or what have you. 8253 timer chip. That went bad. That's this one here. Fortunately, I have spares of all these, and one of the RAM chips, which are pretty scarce. I do have spares of these, though, as well. So I replaced those, and then nothing worked. Well, that is to say, when I powered it back on with 5 volts with those chips in, nothing worked, of course. This chip was pretty much a dead short, so it kind of acted as a fuse and protected the other chips. But no, I got sync problems on the screen. So it was at that point that I finally looked at the 8253 datasheet. Now, some of you may be asking, why are you trying to interface an Intel timer chip to a Motorola part when Motorola makes a timer chip, or made, I think it's the 6840. And it's like, I probably could have tracked down a 6840. The thing is, and I don't particularly like Intel, but I had this chip, okay? It's a ceramic 8253 with a date code of 1978. And so I thought, I'm going to use that, or I'm going to try to use it anyway. Well, it wasn't working, but this Toshiba chip worked that I had. This is a 8253-5. Somehow it worked. This is an Intel 8253-5, and I have another one, which is a Mitsubishi 8253-5. So when I hooked it back up, put in the Intel chip, I got weirdness, right? So then I looked at the data sheet, and it's like, oh yeah, okay. I was connecting the read and write signals to the chip, basically directly from the processor, and that wasn't meeting the setup and hold times that the chip requires. So I had to do a little rework, and I added this bodge board here. No, that's a barge board. This is a bodge board. This is a 74LS31, which is a delay element chip. Now you might ask, so I'm clocking this. Well, the read and write signals are taken off of the Q clock and then conditioned with Q clock delayed and then conditioned with the read and write signal from the processor. Now there's also an E clock out of the processor, and you might say, well, why didn't you just use that? Because that's delayed 250 nanoseconds from the Q clock. So there's your delay, right? Well, the problem with that is that that wouldn't have met the hold time on the chip. And if I had ANDed it with the Q ANDed with E, then I would have only gotten a 250 nanosecond pulse, and these need like 400 nanoseconds. So the Q is 400 nanosecond, 500, Q and E each, 500 nanoseconds high, 500 nanoseconds low. So basically I needed to use the whole Q half cycle or E half cycle. So I needed the Q cycle delayed by about 100 nanoseconds, and that's what the delay elements provided. So having done all that, the thing is now back and working again. And that weird problem that I showed in an earlier video where sometimes when I first started it up, when it started up cold and it wouldn't sync, that's gone. So that was an issue with the timer chip as well. So, lessons learned. Set your power supply so that it turns on to the power you need, or to the lowest voltage you might possibly use, right? So this has 5 volts, 12 volts, 3.3 volts, and 15 volts. I've now moved the 5 volts to M1. I should probably put 3.3 volts on M1, because then if somehow you accidentally hit the power on here, it won't hurt anything, because 3.3 is the lowest I would need. If I needed 1.8 volts for something, then I would put that as the lowest. But if you're using 5 volts a lot, as in this case, make that the power on. I mean, that should be obvious, but it wasn't. And let's see. Anything else? Well, yeah, there was another issue. I had to latch the output of the IRQ signal. So this timer chip puts out 3 timer signals. One's a 60 hertz, which is used for vertical refresh, which goes to NMI, which is edge triggered on the processor. There's another one which is used for horizontal refresh, and that's 15,873 hertz or whatever. That I think goes directly to the video circuit. And then there's another one which is at 26.63 hertz, which I use for general timing and will be used for the sound chip as well to sort of count beats. But I'm using it for general delays. And that goes to the IRQ input on the chip. Well, that's level triggered, not edge triggered. And I'm using mode 2. You can look this up in the data sheet. I'm using mode 2 on this counter chip, which gives a very short pulse when it reaches the terminal count. So if it happened to be in the NMI handler, which actually takes some amount of time because it's doing the painting of the screen, which is some number of milliseconds probably. So it was missing those pulses. So I had to latch those. Fortunately, I had an available latch. This chip here is the switch debouncer. You've seen the switches, right? And it has 4 reset latches in it, and so I had a spare, and so I used that to latch that signal before going to IRQ. That can be delayed. It won't cause too many problems. That 60 hertz NMI signal cannot be delayed. That's for sort of critical timing. So that's why that one's on NMI. But this one, can vary a little bit, and it won't cause any problems. So as I power this on, we'll see, boom, it comes right up into the starting screen. No more, weird sync problems. And I don't have the buttons hooked up, so let me go and set all the switches to their normal state, okay? And then when we drop a coin in, wait a minute, here it is. You've seen this in another video. This is the coin acceptor. That will ground this pin, and so watch here, credits, boop, and this isn't debounced, so it might, okay, there's 1, 2, so you can see I can accept coins. And now when I press the start button, which is this one here, so I press it and I release it, then it goes into the game introduction, which is sort of all I have right now. Now you're going to see these delays are off of that 26 hertz. It might look like here this has got a graphics mode. You'd say, wow, it's displaying graphics. Actually, I kind of cheated, and I'm using, I've got 2 separate character sets in this font ROM, and so there are 3 images here, and they take up 3/4 of one of those fonts. Okay, and so then here's the board, and you'll see occasionally rats going across the bottom. This is just outputting the value of the random number generator, so I can make sure that it doesn't ever hit 0 or get stuck in a tight loop or anything like that. And so that's the current state of it now. This game is called TacoBot. I first wrote it. It's a stupid game, which is sort of a really dumb version of Tetris, almost, sort of. It's kind of like Tetris, but not really. It's just a really stupid game, which I originally wrote on the stupid computer. So you can go find those videos and look if you want to see how that looked on an ASCII terminal. But this is the playing board here. It'll count tacos. What you're doing is you're making tacos, and the pieces of the taco will appear here, and they'll fall down, and you can move them right and left to make them to make complete tacos. Of course, occasionally the rats come along and eat all the tacos on the bottom row, so that's what you have to watch out for. Anyway, that's the state of the world. I just wanted to give an update because it's been a little while. But like I said, I had to work through these user error problems, and I don't know. I mean, like I said, these 3 chips were the ones that were bad, but the others presumably got stressed and they may fail on me. But as of right now, I've got a good solid screen. Everything is working.